I'm Anil Kumar, and in this video we'll explore inverse functions. The question here is inverse of every function a function? Think about it. What I will do here is sketch few functions and then we'll figure out. So let me sketch few functions while you spend time in thinking about it, and then we'll figure out whether all these functions inverse. Will that be a function or not? And how can you say from the graph that your result is correct, right? So this is what we are going to figure out from these three examples. So let me sketch a couple of functions here. So one of the functions will be kind of like this. Okay, so this is my function, one of them, and then let me sketch a function which is kind of like this. Okay, and then one more function which I want to sketch here could be kind of like this. This is also a function, right? So these are the three functions for us. You need to figure out whether their inverse will be a function or not. Now, when we do inverse, we can do it in a couple of ways. One way is we could reflect the graph on the line y equals to x. Right? We could reflect the graph on the line y equals to x and then see whether the inverse is function or not. That is one way we could do. But definitely the easy way out is to draw a horizontal line, right? So if I draw a horizontal line and if it crosses 2 points or more, then the inverse is not a function. So this is called the horizontal line test. Now if I draw a horizontal line, here also it crosses. Do you see that? So it crosses many points. So inverse of functions which fail this horizontal line test will not be function, right? So we have a test which is called horizontal line test. So the functions should pass horizontal line test for their inverse to be a function, right? So that is the idea. So it states that if the function passes horizontal line test, that means that line cuts the graph at only 1 point. So each and every line. So even if a single line cuts the graph at more than 1 point, then it fails. So if the function passes horizontal line test, then the inverse of a function will be a function, right? So that is very important to understand. Now, another way to put the same thing is that only one-to-one functions are inverse functions. The other way to look into it is only one-to-one functions inverse is also a function. Now let me give you some examples which you can use for that test. For example, let us take a function f of x as equals to, let's take few coordinate points, right? Let's say 2, 3, okay, 4, 7, right, 5, 3, okay. Now this is a function since each input has just one output, right? 2 to 3, 4 to 7, 5 to 3. However, if I do the inverse of this, right? So if I do the inverse of this, that means f inverse will be what? We flip the coordinate points, right? So it becomes 3, 2, 7, 4, and 3, 5. Now that becomes the inverse. However, what you notice here is that 3 is linked with two numbers, 2 and 5. Therefore, this is not a function. So this is not a function. Reason is that this is not 1 to 1. Do you see that? Now this is 1 to many. Since it is 1 to many function, its inverse is not a function. Do you get an idea, right? Another way to see it is with the help of graph. So the graph here is, let's do a mapping diagram. And in a mapping diagram, if I'm going to make links from this points to that, however, if this point is also connected with that, in that case, what you notice here is that two points here, let's say these points are A, B, C, and D, are connected to point 1, 2, and 3. Now this is a function, and that is a function f of x. However, if you find inverse of this, then 3 is connected to 2. Then what you get here is you get 3 to C, and you also get 3 to D. Do you see that? And therefore, inverse is not a function. So we say it is not a 1 to 1 function. It is 1 to many, right? So these two, so I should say it is not a 1, it is a I'm sorry, I should have written many to 1. Okay, so not 1 to many. I should have written many to 1. Okay, so I'm sorry for this. If the function is many, see, 2 and 5, so two elements are associated with 3. So many are associated with 1. More than 1 is associated 1. Many to 1. So what we have here is many to 1, right? So the inverse becomes 1 to many. So it is not a function. Do you get the idea, right? So if the function is many to 1 is a function. In that case, inverse will be 1 to many, which is not a function, right? So that changes to 1 to many, right? Which is not a function. I hope that's clear now, right? Okay, so only 1 to 1 is a function. Now here is a test question for you to figure out whether this sketch or graph represents a function or not. That's the first question. Let's say this is a horizontal line. Is it a function? Let's say it goes through the point 5. Now we have a function here, and I could always write this function as f of x equals to 5, right? Or y equals to 5, right? So we could say y equals to 5. Now y equals to 5 is a function because it passes the vertical line test. However, it fails the horizontal line test, right? What is the inverse of this? Inverse of this will be x equals to 5, right? So x equals to 5 will be a vertical line like this, right? That is x equals to 5. This is not a function since it fails the vertical line test, correct? So that is another thing which you should do. Now, if I give you an example, how will you figure out that the inverse is not a function? The example is here. If I say y equals to x minus 3 whole square plus 5, now that is a function. Will its inverse be a function or not? Well, if I want to find inverse, I have to interchange x and y and find what y is. And if I do that, let me do it in a different thing. We get x equals to y minus 3 whole square plus 5. Rearrange, we get x minus 5 equals to y minus 3 whole square. And when you do square root, you write x minus 5 square root plus and minus. That gives you two values for y minus 3. Do you see that? And so bringing 3 here will give you 3 plus minus square root of x minus 5 equals to y. So it is not a function. Do you see that? So as you can see here, a quadratic function which is a parabola, the inverse is not a function. Now this is not a function. Now parabola is something which, now this one, at minus 3, 5 is your vertex, right? The value of 5. So this is a parabola which could be sketched kind of like this, right? So at minus 3, we have 5 as your vertex, maybe like this. So if you flip this, you get kind of like this. Do you see that? And that will fail the vertical line test. However, at times what we do is, we may restrict domain. If I restrict domain, and in this case, if I say x is greater than or equal to this value, 3, then we can ensure that inverse is a function. So by restricting domain, we could at times make inverse of function. So that is what we have learned here. But what the main question is inverse of every function a function? The answer is no. The only functions whose inverse is a function will be those which pass the horizontal line test and which are 1 to 1, right? So we have considered two conditions here. One of them is horizontal line test, and the other one is 1 to 1. So those functions inverse will be a function, and all other functions inverse will not be a functions. So that is what we have learned here. And we have also seen that at times we could restrict the domain of the function. For example, here, if I say let the domain be greater than this value, for example, greater than this value, then the inverse will be a function, because then it is going to pass the horizontal line test. Do you get an idea? If I restrict my domain here to be greater than 0, in that case, this quarter circle here will be a function, and its inverse will also be a function. So by restricting the domain, we can ensure that function's inverse is a function. So that's another thing which we learn. I'm Anil Kumar, and I hope it makes some sense. If you like, you can put some likes. Feel free to subscribe. Thank you, and all the best.